Today I'm going to show you the integration between E3 series and CREO. Here we have an E3 cable project, which is part of a rolling stock vehicle design. Now showing you sheet 1 with the connections between the box on the bogie and the measuring equipment. You can also see sheet 2. We're looking at a simple connection between two D-sub connectors. You can see this can be viewed in various ways, allowing you to create multiple types of documents in one project. Here I am now zooming into the schematic and these connectors. You can see the connections between them and the area of the box. There's the terminal strips on the inside of the box and the connectors on the outside. I'm now opening the device properties of the 4-pin Deutsch Mail connector to show the component tab. This contains important information provided by the vendor of the component. All of this, the component data sheet, is stored in the E3 series library database. On this same topic, I'm going to show you the component table of the Harting modular connector here, where you can find not only the data sheet, but also the component views and a real 3D model. Like before, these details are stored inside the E3 series intelligent library database. With the brief introduction over, let's take a look at the lengths. Here I'm showing the locations where the length will be shown after it's been determined by CREO. Yet at this point, the attribute text template still shows that default 0 value, as we don't yet have the data from the MCAD system. So E3 series has the whole story, except for the length. Now we'll go to the mechanical tool via the 3D Routing Bridge to complete the picture. The 3D Routing Bridge is part of the E3 series environment, and it allows you to export data from E3 series to mechanical CAD, in this case CREO, shown as Pro E. CREO offers two outputs. In this case we're using XML, but NWF is also supported. The Xml file itself includes the connectors, their pins, and the wires and cables that connect them. I'm going to select the desired wires by marking them out in the 3D Routing Bridge module to export. These wires and cables are also highlighted in the project. The level of detail to be sent to the mechanical system can be determined under the Options tab, depending on your requirements. Here in the CREO environment, with the 3D model of the bogie that already has the wires and cables routed, it's not a complete design because all the graphics aren't displayed here, just to try and keep it simple for you. You can see the bogie box as you saw in E3 series moments ago. There's models and various different cable tiles already mounted in their destinations. Now I'm going to open the auto-designated function here in CREO, where the 3D models have already been designated, which means that the model is connected with detailed information about a component. Every model has a name and a set of parameters that also includes wires. Looking down the left-hand side here is the wire or cable harness. The components are connected with the actual wires and cables that have physical parameters such as thickness, cross-section, or bend radius. I'm going to show you how to import that XML file from the 3D Routing Bridge with the detailed information about used elements in the E3 series schematic now. You can see it's a simple process. It allows you to easily update the component and wire harness details, which will allow you to check for new or changed elements. And it's the same process for the initial import as for further subsequent changes done in E3 series, or in CREO for that matter. Now to designate the elements. I'm going to use the automatic designation functionality and some manual clicking to finish off the process as well. After you've updated the wire cable harness, the connections are shown here. I'm going to quickly speed through the process of routing the cable in CREO. There we go. Done. Now you save the file as an XML. This contains the added wire length information, which was measured automatically in CREO. Back in E3 series in the project, to import the XML file, you first open the 3D Routing Bridge module on the Import tab. Using the same XML file, you import data back to E3 series. The good thing about the 3D Routing Bridge is it also prevents any errors during import by checking the information stored in that file. So here we are. Finally, the end result is that you can see the correct lengths which can be used for manufacturing with E3 series. Thank you for watching and listening to this movie. Why not check out further movies on zuken.com or YouTube?